and hence it is the discipline of experimental psychology that gives psychology its scientific basis, because it employs a lot of scientific and empirical techniques to research various aspects of human and animal thought and behavior. Now, experimental psychologists work in a wide variety of settings, whether it is in universities, research centers, colleges, private organizations, or as students, and the applications are many. They may conduct a number of researches in a number of areas, say for example animal behavior, cognitive processes, neuroscientific processes, neuropsychological processes, personality, and so on. Now, if you have a look at slides 1, 2, and 3, you will see the historical development of experimental psychology and the main events therein. Let us go over a few main details. For example, we know that in 1874, Wilhelm Wundt published his first experimental psychology textbook, which is known as the Principles of Physiological Psychology. Now, in the year 1879, Wilhelm Wundt established the first ever psychological laboratory applying experimental techniques in Leipzig in Germany, and this was perhaps the one major landmark event in the history of experimental psychology. Later in the year 1883, as you can see, G. Stanley Hall established the first psychological lab in the US at Hopkins University. Then, as we can see in slide 2, in 1885, Hermann Ebbinghaus put forward his entire novel experiments on the basis of learning and memory in terms of nonsense syllables. And in 1887, James McKean Cattell established the world's third psychological laboratory at the University of Pennsylvania. Then if we see in 1890, William James published his classic textbook, Principles of Psychology. Then in 1891 again was a landmark in the history of experimental psychology, because Mary Calkins established the first psychological lab. She was the first woman to establish a psychological lab, and it was established at Wellesley College. And in 1893, Stanley Hall established the American Psychological Association, which is the largest scientific and professional body of psychology and is involved in a lot of experimentation and research in all fields of psychology. Then we have John B. Watson, we have Edward Boring, and others who contributed in their own way to the development of experimental psychology. Then in 1955, Lee Cronbach published Construct Validity in Psychological Testing, which popularized the use of construct validity in psychological tests and gave an impetus to the experimental field of psychological testing. Then we have recent experiments such as in 1958, Harry Harlow published his book The Nature of Love, in which he, on the basis of his experiments on rhesus monkeys, put forward his theories of attachment and love. Then in 1961, as we know, Albert Bandura conducted his famous Bobo doll experiments to put forward the role of modeling in observational learning in our day-to-day life. Thus, we can see through the years a number of events, starting from, if we can say, Wilhelm Wundt's first laboratory in 1879 at Leipzig in Germany. From then on, a number of experiments have been conducted, and even after Bandura, there were a number of researchers who through the years conducted a series of experiment and research, and it is due to them that we now have such a body of theory and a theoretical basis for our discipline. Now, experimental psychologists use a variety of methods to conduct their experiments. Of course, true basic experimentation remains the most favored method, yet since we are dealing with behavioral sciences, such a laboratory experiment may not be possible in all cases, and hence case studies, correlational methods, and naturalistic observation are also seen as equally potent methods of experimental investigation in psychology. Now, the basics of conducting an experiment in psychology involves randomly assigning participants to different conditions, determining what is the independent variable and what is the dependent variable, determining what are the extraneous variables, formulating a hypothesis, and then finally manipulating the independent variable to see its effects on the dependent variable. Now, as we have seen, deciding which are the variables of the research is one of the basics of conducting any experiment in psychology. Now, what is a variable? A variable can be simply defined as something that varies. But of course, psychologists go in for a more precise and scientific definition. They see variable as any characteristic or attribute which can be manipulated, measured, or controlled by the experimenter. Now, variables are of two kinds. The first type is independent variable and the second type is the dependent variable. Now, the independent variable is that variable which is manipulated or controlled by the experimenter. On the other hand, the dependent variable is that variable about which the experimenter makes some kind of prediction. Now, the basis of an experiment is to manipulate the independent variable and to see the effects of this manipulation on the dependent variable. And so the dependent variable is also sometimes called the response variable and the independent variable the stimulus variable, because the dependent variable responds to the changes in the stimulus variable or the independent variable. For example, say an investigator wants to know as to which of the teaching methods, there are three teaching methods, teaching method A, teaching method B and teaching method C. He wants to know which of these three teaching methods will lead to a higher degree of academic achievement. Here, teaching methods form the independent variable and these are manipulated in three ways, A, B and C, and the dependent variable is the academic achievement. And depending upon the action of the teaching method on the dependent variable of the academic achievement, the investigator can draw some conclusion regarding which method is most effective. Now, there are two concepts with regard to dependent variables that we need to analyze. The first is the floor effect and the second is the ceiling effect. Now, when most of the subjects score at the very end of the scale, a floor effect is said to have occurred. This is because the task is so complex that none of the subjects can perform well on the task. For instance, if you give them a task of analyzing the qualities of light or the colors of light and all the lights are below the threshold for clear perception, then it becomes very difficult to go about the task and hence most of the subjects score below normal, resulting in a floor effect. The opposite of a floor effect is the ceiling effect, where the task is so simple that most of the subjects go ahead and score at the highest ends of the scale. For instance, in the same task of discriminating between different lights, if the lights are very bright and very clear, then it is very easy for the subjects to discriminate between them. Thus, we can see that a floor effect or a ceiling effect occurs when the dependent variable cannot in fact track the full extent or the full length of changes in the independent variable. Now, there are three necessary characteristics of a dependent variable. For a dependent variable to be effective, number one, it must be sensitive. It must be sensitive to changes in the independent variable or it must change according to changes in the independent variable. Point number two, the dependent variable should be valid or it should measure what it seeks to measure. The third is that the dependent variable should be reliable. What do we mean by reliability? Now, if students respond, say, in a particular way to teaching method A, they or other students should also respond in the same way to the same independent variable, that is teaching method A. Suppose if the same students or different groups of students respond in very different ways to the same independent variable, say teaching method A, then the reliability decreases and we say that the dependent variable is not reliable. Now we come to two features of the independent variable. These features can be understood in terms of how the independent variable is manipulated. Now, there are certain independent variables which we can manipulate directly. For instance, if the experimenter wants to know what is the effect of temperature on reading skills, then he can directly manipulate the independent variable of temperature. He can provide situations with a high temperature, with a moderate temperature, or with a low temperature and see the effects of the same on reading ability. And such variables are called type E independent variables because they can be manipulated directly. Now, there are another class of independent variables which cannot be directly manipulated. For instance, there may be a number of subject relevant characteristics, say age or gender. Here we cannot apply a direct manipulation. We cannot directly manipulate age or directly manipulate gender. But we can manipulate these variables through selection. For instance, we can select people of a particular age group, say children, to form one group of subjects. We can select another age group, say middle-aged people, to form another manipulation of the independent variable, and so on. Here the manipulation of the independent variable of age is not direct, but rather it is through selection, and hence such independent variables are called type S independent variables. Now we saw how independent variables can be classified into type E independent variables and type S independent variables depending upon direct or indirect manipulation. Now we will see another form of classifying independent variables depending upon their nature. Depending upon their nature, independent variables can be classified into subject relevant variables, task relevant variables, or environment relevant variables. In subject relevant variables, the independent variable is the characteristic of the subject, say for example age, sex, intelligence, and so on. If an investigator, for example, wants to know as to how people differ in their reading ability depending upon their levels of intelligence, and he selects groups of people having different levels of intelligence, then this forms a subject relevant independent variable. Now a task relevant independent variable is when aspects of the task form the independent variable. For example, an experimenter may want to know as to how complicating an experimental situation will have some effect on the dependent variable, say the individual's performance or the individual's anxiety. For instance, he may give 3 tasks, one of a moderate intensity, a simple maze task for instance, or something of a highly complex intensity. He may add a number of blind alleys to the maze and increase the complexity of the task and see the performance of the individual on the basis. So here the task itself becomes the independent variable which is manipulated. The third kind of independent variable is the environment relevant variable, or aspects of the environment become the independent variables. For example, if the experimenter wants to know how individuals can perform in differing levels of temperature. Now temperature, as we know, is an environmental variable, and he may vary the temperature into a high temperature, moderate temperature, and low temperature and see the performance of individuals in these manipulations of the independent variable. So thus we can see that there are 3 types of independent variables depending upon their nature, that is subject relevant, task relevant, and environment relevant independent variables. Now we come to yet another type of variables, that is the extraneous variables. Now extraneous variables are those variables that exist in an experiment along with the independent and dependent variables, and they exercise their influence on the dependent variable along with the influence of the independent variable. So when there is a functioning of extraneous variables, there are 2 kinds of variables bringing about changes in the dependent variable. One is the independent variable and the other is the extraneous variable. But the effects of the extraneous variable is not something which the researcher wants to understand. He only wants to measure and isolate the effects of the independent variable on the dependent variable. And hence, in all experimental situations, he will try his best to control all these unnecessary variables or extraneous variables which bring about unnecessary changes in the dependent variable. Say for example that the experimenter wants to see the effect of a certain level of temperature on reading ability, and temperature is his independent variable. He may classify temperature into high temperature, low temperature, or moderate temperature and see the effects on performance. But temperature may not be the only factor affecting performance. There may be other factors such as noise, other distractors, as also variables within the person such as his level of intelligence or his age or his physical capacities, which may be affecting his reading ability. So this brings about confusion, and the investigator cannot see clearly whether the reading ability has been influenced by the temperature or not. And hence it becomes essential for him to control all other factors such as noise, age, intelligence, and so on, and isolate the effects only of temperature on reading ability. Now that we have distinguished between independent variables and dependent variables, now we'll distinguish between other types of variables. One type is quantitative versus qualitative variables. A qualitative variable is a variable which cannot be ordered in magnitude. For instance, we cannot say that a person X, for example, has a greater magnitude of that particular variable than a person Y. Examples of qualitative variables include sex, race, religion, and so on. For instance, we cannot say that the person X has a greater magnitude of a characteristic, say religion, than person Y, or a greater magnitude of a characteristic such as race than person Y. On the other hand, quantitative variables are those variables which can be ordered in magnitude. For example, age or intelligence are examples of quantitative variables. We can say that the person X has a greater age than person Y, or person X has a greater intelligence than person Y. Now, two other classes of variables are continuous variables and discrete variables. Continuous variables are those variables which can be divided or reduced to any arbitrary degree of fineness. An example of a continuous variable would be age. We can divide age into years, months, days, minutes, or even seconds. We can even say that a person is, for example, 6 years old, 6 years, 5 months, 4 days, 3 minutes, or any such kind of arbitrary fineness can be brought about into the measurement. On the other hand, discrete variables are those variables which cannot be divided into any arbitrary degree of fineness. For instance, say the number of members in a family. We can either say there are 2 members or 3 members or 4 members. We cannot say there are 2.5 members or 3.2 members and so on. So, any arbitrary degree of fineness is not possible in case of discrete variables. Now we come to two other types of variables, that is moderator variables and intervening variables. Moderator variables are those variables which the experimenter recognizes and realizes have an effect on the experimental situation. Say for example, he wants to see what are the effects of certain teaching methods on academic achievement. He will know that in this context, not just the teaching methods but another factor, that is intelligence, will have an effect on academic achievement. So he recognizes this moderator variable of intelligence and makes maximum efforts to control this variable so that only the effects of the teaching methods on academic achievement are isolated. Another class of variables are the intervening variables. Now, intervening variables are not variables actually manipulated or controlled by the experimenter. They are not even mentioned in the experimental design. They are aspects of the independent variable itself which bring about changes in the dependent variable. For example, if the investigator wants to know as to what is the impact of bringing certain obstacles in the tasks that you are doing on feelings of aggression, then naturally if the subject feels aggression, this will be because of one aspect of the independent variable, that is frustration, because obstacles lead to frustration and this frustration causes aggression. So frustration is nothing but an aspect of the independent variable of obstacles, and this frustration therefore becomes the intervening variable. Now we come to a second important part of this lesson, that is errors in experimentation and the sources of errors in experimentation. Now firstly, let us know that errors in experimentation are basically of two kinds. They can be random errors or they can be systematic errors. Random errors are random fluctuations in experimental measurements which occur either due to slight changes in the measuring instruments or the inability of the experimenter as a human being to bring out exact measures every time. For instance, even if you measure a certain object, say a ring, a certain number of times, one time the measurement may be 17.4 grams, another time it may be 17.43 grams, and so on. Slight changes may happen in any direction. Now, systematic errors, on the other hand, are errors due to some fault or some lapse in the experimental situation, and these errors continue throughout the course of the experiment in a particular direction. For example, if you take a common example, if you are using a tape measure to measure a cloth and the tape is stretched because it is very old, then all your measurements for all the clothes will go wrong in the same way. Now, since we have seen what are random and systematic errors, we come to the sources of errors in experiment. The first source is history. The error of history occurs because every participant comes to every experimental situation with a history or a background of his own, with a number of experiences that are unique to him and that influence him during the course of the experiment. Now this, as we can see, is a random error and it can lead to a fluctuation in the measurement in any direction. The best way to control this error is to take pre-test measurements so as to have some degree of knowledge regarding the subject's condition prior to the experiment. A second kind of error is the selection error. This happens when participants are not selected randomly from the population, and certain part of the population may be overrepresented, certain other part may be underrepresented, and it leads to a bias in the results, and the results cannot be generalized to the total population. Now this is a systematic error, and the way to prevent this systematic error is to engage only in random selection of the sample from the population. Now a third source of error is experimental mortality. Experimental mortality happens when certain subjects drop out in the middle of the experiment, and hence there is a lot of problem in actually inferring the final results of the experiment. Say for example, you are trying a drug treatment for a particular disease, say cancer, and during the course of the treatment and during the course of the therapy, some patients, especially those who are in advanced stages of cancer, dropped out. So what happens is that the result you will get at the end of the experiment will be unnaturally positive, because the severe cases dropped out, and of course the therapy will be more useful for those who had milder cases of cancer. Another source of experimental error is the diffusion of treatment. Now what is the diffusion of treatment? Say for example, you have to give an experimental treatment to one group of subjects, that is group A, in the morning, and the same treatment to another group of subjects, group B, in the evening. Now after getting the treatment, subjects in group A may actually meet prospective subjects of group B and tell them what happened in the experiment. Say, this is the way I was tested and these were the procedures used. So this will actually reduce the effectiveness of the treatment for the group B person. So how do you control this kind of systematic error? The way to control it is to actually arrange situations in such a way that participants in one condition do not get to meet participants from another condition, and also instruct the participants not to go out and spread information about the kind of experimental treatment they received. Another source of error is maturation. Especially when experimental treatments take a long period of time, a number of maturational changes regarding age, health, ill health, and other many such factors happen in the subject which can affect the validity of the experiment. So the best way to control this form of both random and systematic error is to keep experiments as short as possible and to take baseline and pretest measures to ensure the impact of maturation on the person from one condition to the other. Another form of error, which may be seen as a sixth form of error, is the error of response cycles. When we ask individuals to respond in a particular way, say yes or no, and such ways, they may actually form a tendency of responding. They may respond either only yes, 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 or no, 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 or they may have some kind of sequence in responding. So it is best to use different measures of responses, such as Likert scales, where multiple responses are possible or multiple options are given. Also use many techniques to get the same information from the person, so that when you put together all the information, you can have an idea of whether the information is reliable or not. Another source of experimental error is the order effect, and this happens when the same participants have to undergo different experimental treatments or the same experimental treatments a number of times, and hence two factors can occur. One is practice, because they already know what an experimental treatment is like. That experience carries over to the next treatment. Or it may be fatigue, because they are so tired being participants in different experimental treatments that the effect of fatigue affects the last occurring experimental treatments. Here the technique of counterbalancing can be used to avoid this kind of systematic error, so that every experimental treatment precedes and succeeds the other treatments, and hence even if there are effects of practice and fatigue, they tend to balance out. Another very famous effect is the Hawthorne effect, where subjects perform in a particular way just because they know that they are in an experimental situation. Just the knowledge of being in that situation makes them behave in certain ways. The way to control this actually is to create blind studies where the subjects do not actually know that what they are doing is part of an experiment. This would give a more naturalistic way of observing their behavior. Another kind of error happens through experimenter bias, because the experimenter knows his hypothesis, he knows the assumptions, and therefore through some kind of conscious or unconscious clues or suggestions, he may affect the performance of the subject. For instance, he may give certain suggestions or certain kinds of clues which may influence the subject's responses. And this can be avoided by adopting a double-blind study where the experimenter who is actually performing the experiment is not the researcher who has formulated the hypothesis. So both the experimenter and the subject do not know what is the actual purpose of the experiment. Now, errors can also happen due to inconsistencies in the measuring instruments or in the inconsistencies of observations of various researchers who are doing the inferences, and hence the best way is to take as much data as possible collected from various sources and try to average this data to find out the most approximate or most correct inference. Another error happens when the principle of constancy of conditions is violated and the control group and the experimental group have certain different conditions. Certain factors operating in the control group may not operate in the experimental group, and hence the equality of these two groups is not maintained, and hence it becomes difficult to understand whether the effect in the dependent variable is because of the independent variable or certain other extraneous variables that are operating. Now we'll be finally discussing three last types of errors. The first is the error of statistical conclusion or statistical calculation, where the errors in inference or conclusion happen because the statistical techniques or the statistical measures that you are using are wrong, and hence to prevent this systematic error, it becomes very necessary to analyze whether the kind of statistics that you are using are particularly applicable to your experimental situation or not. Another source of error is statistical regression. This is a tendency in which when you take extreme groups of people from the pre-test to the post-test, their scores tend to move towards the mean. For example, if you test a group of extremely low achievers, then their scores will actually improve from the pre-test towards the post-test. In the second test, they may actually show a better level of achievement. Now, this is not because of any kind of intervention, and when you say that this is because of the experimental intervention, you will be wrong, because this is due to the normal process in which behavior occurs or due to normal regression tendencies of scores. A third source of experimental error is testing, where the changes or the scores on the post-test are not because of the experimental intervention, but are because of the introduction of the pre-test. I will give you an example to understand this. Say, for example, you give the students an academic test, and then this becomes the pre-test. And then you give them some kind of academic training, and you again give the same academic test as the post-test. Now, the improvement in scores from the first pre-test academic test to the post-test academic test may not just be due to the training or the intervention in academics given in between, but it may also be due to the fact that the students have some kind of experience in solving the same type of problems. They solved the same problems in the pre-test and they carry over that practice to the post-test. So it becomes difficult to understand whether these are carryover effects or whether they can be assigned to the effect of the treatment or the academic training. So in this chapter, we have seen the origins of experimental psychology and the major landmarks in the history of experimentation in the field of psychology. Finally, we have seen one basic aspect of conducting any kind of research, the basic primary aspect, that is variables and the types of variables. Finally, we have also seen the sources or the possible sources of errors in experimentation and the ways in which we should control them so as to ensure that our experiment has a high level of reliability and validity.